Welcome to the journey of evolution and passage of time regarding the age of Earth and its essential phases of formation. The age of Earth is believed to be around 4.5 billion years old, with estimation of the core of Earth as the primary object. Various estimates and techniques has been employed to determine the age of Earth on an accurate basis, with several theories postulated by eminent scientists. Various measures as radiometric dating, meteorite analysis, and samples taken from the Moon has been deployed to determine the age of Earth on a constant basis. Some primitive crystals were found in jackals of Australia were of more than 4 billion years old. The presence of lead in uranium-rich deposits were of more than billion years old. The presence of calcium aluminium-rich inclusions in the meteorites of the solar system were found to be of 4.5 billion years old. It is estimated that the process of accretion of Earth started after the accumulation of calcium aluminium-rich inclusions and the presence of meteorites. Some early calculations regarding the age of Earth has been postulated by various astronomers and scientists of varying calculations and series of predictions. Some eminent scientists like William Thomson, first Baron Kelvin, Hermann von Helmholtz, Simon Newcomb, George H. Darwin, John Joly, and many others estimated the age of Earth in varying proportions. Now let us dive into the important parameters regarding the process of measurement of the age of Earth. Radiometric dating, meteorite analysis, and analysis of lunar samples are primarily used for proper analysis. Radiometric day analysis relies on decay of radioactive isotopes within rocks and minerals. Isotopes decay at a predictable rate measured in half-lives. Scientists determine the age of Earth by analyzing ratio of parent isotopes to daughter isotopes. Meteorite analysis provides into age of solar system, including Earth as there are remnants of early solar system. Radiometric dating techniques are applied in meteorite samples for age determination. The radiometric dating of lunar samples determine age of Moon as a polar emission brought back rock and soil samples. Age of Moon is closely linked to Earth as massive collision was formed between an object of size to Mars and early Earth. Early Earth, a hot beginning. The solar system was a violent place with frequent impacts from asteroids and comets. Such impacts helped in the formation of Earth's shape and contributed to its evolution. The gradual accumulation of dust and debris in the Earth's solar system led to the process of accretion. The process of accretion formed large bodies. Larger bodies were formed on account of collision and merging, leading to the formation of planets. Large amount of heat was generated, which ultimately led the Earth to melt. Small celestial bodies formed by accretion led to the formation of planetesimal order. The planetesimals collided and merged, releasing a large amount of heat. The molten outer layer of the Earth led to the evolution of a magma housing. The release of gases from the interior of Earth formed the early atmosphere of Earth. Cooling and solidification. Volcanic eruptions released gases and molten rocks forming the Earth's surface. Water vapor, carbon dioxide, and nitrogen was released into the atmosphere. The early atmosphere was just like a piece of suffocating atmosphere with lack of enough oxygen. The Earth gradually cooled over the time span of millions of years, allowing the crust to form a solid shape. The process of differentiation took place, which separated the layers of Earth into core, mantle, and crust. The densest materials such as iron and nickel sank to the center, forming the core of Earth. Less dense materials formed the mantle surrounding the core, while the lightest materials rose to the surface, forming the crust of Earth. Such impacts led to the formation of Earth's surface and finally helped the evolution of Earth. Evolution of atmosphere and oceans. Gases like hydrogen, helium, and other gases formed the primordial atmosphere. The process of volcanic outgassing released water vapor, carbon dioxide, and other gases. An early atmosphere was eventually formed. The great oxygenation event increased the levels of oxygen in the atmosphere due to the presence of photosynthetic organisms. As the Earth cooled, water vapor in the atmosphere condensed, leading to the formation of rains, and eventually the formation of oceans took place. Welcome to plate tectonics. Some major geological events took place on account of emergence of plate tectonics. Earth's crust is divided into tectonic plates that move slowly over time. Plate tectonics drive geological processes like earthquakes, volcanic eruptions, and formation of mountains. Continental drift is a theory which gives the assumption that continents of Earth move slowly over time. Earth's continents move slowly over time due to the occurrence of continental drift. Large continents were formed by the merging of continents. Various mountain ranges were built on account of the occurrence of plate tectonics. Large landmasses, for example as Pangaea, were formed by the merging of continents. Its geological timescale, folks. The age and history of Earth is divided into eons, eras, periods, and epochs. Major geological events like tectonic plate movements and mass extinctions were formed in these time divisions. Eons are the largest divisions of geological time as of Hadean, Archean, Proterozoic, and Phanerozoic. Eras of the subdivisions of eons are categorized into Paleozoic, Mesozoic, and Cenozoic. Periods of the subdivisions of eras are now divided into Cambrian, Jurassic, and Quaternary. Periods are further subdivided into epochs and are further classified into Pleistocene and Holocene. Climate change. Climate change occurred in various phases with changes through ice ages with the introduction of several time periods. Volcanic cycle brought change in the variation of Earth's orbital parameters which ultimately affect the climatic patterns. Greenhouse effect introduced the family of greenhouse gases which helped in the warming of Earth's atmosphere. The periods of global cooling and glaciation brought forward the emergence of ice ages. Glacial periods brought forward the periods of cold climate with widespread sheets of ice. The emergence of interglacial periods carried forward the periods of warmer climate between ice ages. Anthropogenic climate change was caused due to various human activities. Some major and vast extinction events have occurred in the history of Earth, thereby wiping out quite a large number of species. Possible causes of these large mass extinctions include asteroid impacts, volcanic eruptions, and severe climatic changes. The evidence of life. The emergence of life brought many forms of life on the planet Earth, thereby starting the origin of life in various forms. The process of abiogenesis began where the origin of life started and rose from non-living matter. Organic molecules may have started their journey in the early oceans of Mother Earth, thereby offering the building blocks of life. Life may have started near the hydrothermal vents, where hot water, rich in a quantity of minerals, may have emanated from the floor of ocean. All early forms of life may have originated from the family of simple single-cell organisms. The theory for RNA world hypothesis states that RNA was the mode of primary molecule much bigger than the family of DNAs and the proteins emerged. The process of evolution by natural selection began when organisms had the ability to adjust and adapt themselves to the environment. Human evolution in the Anthropocene. The process of human evolution started from hominid evolution, where the race of humans started from their previous ancestors. The evolutionary history of humans and ancestors all began from this process. Homo sapiens have finally arrived on the scene, where the origin and journey of the race of modern humans began in forms and shapes. Anthropocene epoch puts light in the current geological epoch, where the activity of humans had quite a large impact and effect on the ecosystems of Earth's climate and its various forms. Thanks for watching. Please like, share and subscribe.